Hello everyone, welcome back from spring break. This is the first thing that we're going to be looking at now when we come back that we've ended our break. And the topic is graphing inequalities on a coordinate plane. But in order to do this, I'm going to go back and review really quickly some graphing of inequalities that we did earlier on a number line. Now, when we graph inequalities on a number line, we're really talking about graphing using one variable. So we used to have inequalities like this. X is greater than 5, or X is less than 5, or X is less than or equal to 5, or X is greater than or equal to 5. Now, when we graph these, remember that when we had greater than or less than, we used an open circle because we could not include the number 5. So, for example, we put 5 here as a reference point, and we were looking at all values greater than 5, like 6, 7, 8, 9. But also, as we get closer and closer to 5, it might be 5.1 or 5.01 or 5.001. But we had to guarantee that our x value was greater than 5. So what we did is we put an open circle at 5, and then we shaded our number line and got as close to 5 without exactly getting there. And so all numbers greater than 5 would be to the right on the number line. Now, when it was less than 5, we still used 5 as our reference point, an open circle because we couldn't include the 5, and then it was everything shaded to the left. So for greater than or less than, these we used an open circle at 5 because we couldn't include those. Now, when we had a situation like this, less than or equal to 5, it was everything to the left of 5, but we included 5. And so we would shade in the number 5 itself. Here, greater than or equal to 5, then we would have included the number 5 and then everything to the right. So these are the 4 inequalities that we used when we were shading with one variable on a number line. Now notice here I left one number line and x here by itself, because if we graphed x equals 5, then we didn't shade to the right or to the left. We just shaded one point, which was x equal 5. It was just the number 5 by itself, not shaded to the right, not shaded to the left. And this is the statement, this equals here. I'm going to pick up where we left off right before really when we left for break. If you remember, we were graphing lines, and we graphed them in 3 different forms. This was slope-intercept form. Here's the slope, here's the intercept. We also did standard form, which was ax plus by equals c. And we also did point slope form, which was y minus y1 mx minus x1. So this was point slope form. And I mentioned standard, so I'll just write it here, ax plus by equals c. So these are the 3 forms that we talked about. However, what we're looking at now is graphing inequalities. But this is clearly an equality or an equation. And some values that in a table that might make this statement true could be 0, 3, and if I graphed it on my coordinate plane, 0, 3, 2, and you might say, well, why did I choose a 2? Well, 2 is easy to take half of. So half of 2 is 1 plus 3, so that would be 4. You can see here at 2, 4. I already made a little point there earlier. If I go to 4, half of 4 would be 2 plus 3. That would give me 5. And you can see how these points, as we move to the right, they are going up. Up 1, right 2. Up 1, right 2. Because the slope is a half, the intercept here is a 3. Now, if I continued to draw or graph all the points that made this statement true, I would end up getting a line that would extend to the right and to the left. It would have a slope of 1/2 and it would have an intercept of 3. Now, I said that this was a coordinate plane. This XY coordinate plane extends forever and ever in all directions. But this line now has cut the coordinate plane into two parts. A part on this side of the line and another part on this side of the line. And so what we say is that the line cuts the coordinate plane into two half planes. So, two half planes. One of the half planes is on this side of the line, the other half plane is on the other side of the line. Now you might think, well, here we're graphing an equation, but you said earlier that we were going to graph inequalities. Okay, so now how does our graph change if we change this equal sign to a greater than or a less than, or greater than or equal to, or less than or equal